Hello, ladies and gentlemen, and welcome to Unit 3, Notes 2. So today we're talking about multiplying monomials. Now, a monomial is a polynomial that only has one term. So we're looking at rules of exponents as pertains to one term. So let's start by taking a look at rules of exponents. Okay, so today we're just going to look at a couple of different ones, and we'll look at some more tomorrow. So again, if you need more time to write it down, please pause the video. So the first rule we're going to talk about is multiplying like bases. Now, like bases are things like A and A, X and X, Z and Z, something like that. Same letter means the same base. So when you have two letters that are the same and you are multiplying them together, then you're going to add the exponents. Take a look at the example. We have a to the 6, a to the 3. So that's going to equal a to the 9th. All I did was add 6 plus 3. So we are adding exponents. Let's take a look at some other rules. We'll talk about those two tomorrow. So let's talk about a power of a power. So if we're taking a power of a power, if we're taking a to the 6 raised to the second power, like we see in that example there, we're going to multiply exponents. But here's a trick that a lot of students miss. This 6 also has an exponent of 1. Okay, so we need to take that 1 and we need to multiply the 2 into each exponent. Okay, so don't forget about that coefficient. That also needs to have the exponent multiplied. So 6 to the 1, we're going to multiply 1 times 2, and we get 2. And then a to the 6th, 6 times 2 is 12. So then when you multiply that out, you get 36, a to the 12th. Let's take a look at the next rule, the zero power rule. Anything to the zero power is 1. Now, students get tripped up here, okay? If the whole entire thing is raised to zero power, it is 1. Now, sometimes there are problems where parts of it are raised to the zero power, and only those parts are 1. But if you look at the example written here, the entire thing is raised to zero power, so that's 1. Okay? All right, moving on. Let's take a look at some of these examples. So let's look at some of these and try and practice them. So what I'm going to do is I'm going to do one, and then I'm going to have you guys try some. Okay, so let's take a look at number 1. So we want to combine like bases. Okay, so what we're going to do is I see that this is x to the 1. So the only thing that's similar are those two x's. So we have 4, and then x to the 1, and then x to the 2. So we're going to add those two exponents because they both have x's. And then y to the 3rd is going to stay by themselves. We only add exponents of same letters. Okay, we only add exponents of same letters. So let's take a look at number 2. So number 2 we're going to take and we're going to distribute in that 4. So 2 to the 1 and x to the 1. Remember, each of those, if they don't have an exponent, the exponent is 1. So I'm going to take that 4 and multiply it by each exponent. And that's that rule using a power of a power. So 2 to the 1, 1 times 4 is 4. X to the 1 times 4 is 4. Now I'm going to multiply 3 times 4, which is 12. So all I did was multiply those exponents. You simplify that out, 2 to the 4th power is 16. You have x to the 4th and y to the 12th. And that is your answer on that one. I want you to take a second and simplify number 3 yourself. So ask yourself, when you raise something to the 0 power, what should the answer be? All right, let's take a look at number 4. So for number 4, this looks a lot more crazy than it is. So before I distribute in that 2, I actually want to go through and combine all of my like terms. You'll notice that if there's no exponent, I'm just putting an exponent of 1 to remind myself that that exponent of 1 is there. So 6 to the 1 is going to stay the same. Now here I have x to the 3rd, x to the 1. So I'm going to add those exponents because right here we are multiplying like bases. A lot of students ask, what order should the letters go in? And I usually just say, put them in alphabetical order. That's typically your best option. Next, we have our y's. We have y to the 1st and y to the 4th. So I'm going to write that as y to the 5th. Now, this whole thing is being raised to the 2nd power. Okay, so now I've simplified the inside. Now I'm going to deal with this power of 2. So I'm going to take that 2 and I'm going to multiply it into each exponent. 6 to the 1 times 2 is 2. 4 times 2 is 8. 5 times 2 is 10. So when you're taking a power of power, you multiply like bases. Let's take a look at number 5. Number 5 looks really crazy. Okay, but it's actually not that bad. We're just going to simplify it out. Okay, we're taking a power of a power of a power, which means we can just multiply each of those together. So we have 2 to the 3 times 2 times 2. 2 to the 3 times 2 times 2. Well, that's the same as 2 to the 12th. You can punch that in your calculator. 2 to the 12th is 4,096. Why don't you guys go ahead and pause the video? I want you to try number 6 on your own. Next, we're going to talk about monomials a little more in depth. So when you're looking at a monomial, okay, it is a number variable or a product of number of variables. You'll notice that that is actually the same definition of a term. So a monomial is a term. They are the same thing. Okay, if we only have one term in our polynomial, it's called a monomial. Mono means one. Okay, next thing that you want to know is that monomials that are all real numbers, meaning there are just numbers, there's no letters, those are our constants. We talked about that last notes, okay? Things that are all numbers are constants. You do not have to write this chart down if you don't want to, but if you want it just for reference of what a variable will look like, what a product of a constant and variable, and what a constant would look like, feel free to write down some of those examples. All right, let's take a look at, this is kind of our checklist. So when we're going through these are the things we want to make sure are happening before we move on to the next problem. First of all, we want to make sure that each base appears exactly once. That means there's only one x. And it could be raised to a power, but there's only one of them. There's only one y. There's only one a. They can all be raised to a power, but they're only written once. Next, we want to make sure that there are no powers of powers. So I don't want to leave something as a squared raised to the third power. I want to go through and simplify that. And last but not least, we want to reduce all of our fractions. For the purposes of this unit, you will be reducing all of your fractions. I do not want you using decimals. All right, let's take a look at some of these. This is the majority of what is going to be expected of you when it comes to this unit. Now, take a look at number 7. If there is no exponent out in front, no coefficient out in front. Remember that coefficient is the same as 1. Now here's where students get confused. When you are doing problems like these, when you're multiplying monomials, you are going to multiply the coefficients and add the exponents. So you're going to take 5 times 1. 5 times 1 is 5. Then you're going to add the exponents. Multiply the coefficients, add the exponents. 7 plus 6 will give you 13. I want you to go ahead and try number 8 on your own. It's really the same thing as I just did, except this time there's 2 letters instead of 3, instead of 1. And we're going to move on to number 9. Now, number 9 looks like it's going to be a little ridiculous, but we're just going to take it one step at a time, and we're not going to stress ourselves out too much. So the first thing I'm going to deal with is I'm just going to deal with simplifying that portion right there. So I'm going to leave 3x y to the 4th at the same. Okay, then I'm going to simplify. Remember, if there is a negative, what I want you to do is put a parenthesis around it and raise it to the 1 power. Think logically. If you square a negative number, it should be positive. Please be smarter than your calculator. If you square a negative number, it should be positive. So we take -2 and we square it, and that gives us 4. Here we have y to the 1. 1 times 2 is 2. However, that parenthesis right there is still being raised to the 3rd power. So I'm going to go ahead and I'm going to keep simplifying. So I'm going to keep my 3xy the same. And now I'm going to distribute in here. That's the same as 4 to the 1. So I'm going to take that 3 and I'm going to distribute it into each exponent. Because I'm taking a power of a power, I'm multiplying exponents. So we have 4 to the 3, y to the 2 times 3, which is 6. Now, let's multiply all of those together. So first thing we're going to do is multiply coefficients. So we're going to take 3 times 4 to the 3rd, which is going to give us 192. Next, we're going to take our x's. Okay, we don't have an x in the second term, so that's just going to stay as x down there. Last but not least, here, this should be y to the 4th. So here we have y to the 4th. And y to the 6th. Now remember, when we're multiplying things of like bases, we add the exponents. So that's going to become y to the 10th. All right, so don't get too intimidated. I want you to try number 10 on your own. And here are my suggestions. First thing I want you to do is to simplify just this part. Now remember, when you square a negative number, it should become positive. And then I want you to square it on the outside. And then all you're going to do is distribute in this 3 to each exponent. So take your time on this, pause the video. I do ask that you take this seriously. It is important that you try some of these on your own. Let's take a look at this word problem. Express the area of a square as a monomial. So a monomial for each of the sides. Now, to calculate the area of a square, We're going to use the formula length times height. So now I want to take, and I'm going to basically multiply the length and the height, or the width. Either way, with a square, it doesn't really matter. So for the area, I have 4AB times 4AB. Well, this is this, oops. Each of these A's and B's are being raised to the first power. Okay, they're being raised to the first power. So what I'm going to do first is I'm going to multiply the coefficients. 4 times 4 is 16. Then I'm going to look at my A's. When I'm multiplying things of like bases, I add the exponents. So you add the exponents and you get 2. Then I'm going to add the exponents on the B's and you get 2. All right, so here you get 16a squared b squared for your final answer. Okay, remember when you multiply things with like bases, you add the exponents power of a power, you are going to multiply the exponents. So I'm going to have you guys do this one on your own. Here's what I'll tell you. The area of the triangle is 1/2 base times height. This is your base right here. This is your height right here. So all you're really doing is multiplying those two together and then multiplying it by a half. So go ahead and try that when you're done. Once you're done, go take the Schoology quiz, and hopefully you've worked really hard on these problems so that the Schoology quiz will be a snap for you. And I will see you tomorrow.